Another example with circular motion is this conical pendulum that rotates around in a circle like this. And so this is, you can see it set up with this problem as a 50 kilogram mass. So the mass is equal to 50 kilograms. And the string is 10 meters at a 15-degree angle. And it asks first to draw the force vectors. And so the force vectors are that we just have mg that's down, and we have tension that's up. And that's all the forces. Now, we can set up this force diagram. We've got mg, and then this tension actually has components, right? So here's tension. There's a y component, ty, and tx. And what we can realize if we do the sum of the forces, so the net force in this diagram is pointing actually in the x to the left here. Okay, and so we're supposed to first find the tension force. So we can say the sum of the forces in the y direction equals 0 because there's no acceleration in the y direction. It's not accelerating up and down. But the sum of the forces in the x direction equals mass times the acceleration. And so if we look at what's happening in the y direction, we can say tension in the y is equal to mg. So if this is 15 degrees, then ty, if we just set up our triangles as usual, then ty is tension times cosine of 15 degrees would then be equal to mg, or the tension would be equal to mg in this case over cosine of 15 degrees. And so that gives us a tension equal to 507 newtons. Now, so that's this question number 3. Question number 4 says calculate the acceleration. So to find the acceleration, we need the tension in the x direction, right? So tension in the x direction equals mass times the acceleration. So to find the acceleration, we need the tension in the x, which would be tension sine of 15 degrees, right? Because that's tx, so that's opposite the 15 degrees, is equal to mass times the acceleration. So that gives us a 507 newtons times sine of 15 degrees is equal to 50 kilograms times ax. So ax is equal to, so I get an ax after I do this calculation of 2.63 meters per second squared. Okay, so the last question asks to find the velocity, find the speed actually, and then the velocity is going to change direction, right? As this goes around in a circle, the velocity is going to change directions as we work our way around the circle, but the speed is going to be set. And so then we could say ax is just going to be v squared over r. So we have ax, we just need r, so that would be this distance here, which we can again get because sine of 15 degrees is going to be r over the length, that hypotenuse of 10 meters. So then r is equal to 2.59 meters. And so we can plug this r right in here, this acceleration right there to get the speed squared. So the speed squared is just a times r. So if I multiply those, okay, that gives me a speed squared of 6.8 meters per second squared. So v is equal to the square root of that. So I get about a 2.6 meters per second. The point of this is that once again, you can use force diagrams to figure out what's going on. So if you know the angle that something is able to go around in a circle, then that actually tells you then what its speed must be.